Welcome to day 15 of Advent of Code 2022. I think this is gonna be a bit challenging today, but you know what? If we take small steps, I think we can make it. And this is what I want to do. I'm starting by pasting the input in a local text file. I am using the template, I'm using everyday, and I'm gonna parse this file. And here we log the lines. So I forgot to comment that out. Yes. So here, nothing crazy for now. We just log what's happening here. And we want to do some parsing. So here I am going to be using a nice regular expression. Line. I'm going to go through each line and we're going to be using this regular expression, which is, yeah, there's the minus here that we need to take into account. Yeah, that's fine. So we say here this is, there can be a minus and then it should be one or more integers. That's going to be the pattern that we're going to repeat, and here we're going to name that. We're going to name that, wait, how do we name that? Like that. We're going to say this is sensor X. And we're just going to repeat that. Sensor Y. Here this is beacon X. Beacon X. And here this is beacon Y. So this is const reg exp. This is our regular expression, and I'm just gonna put that outside of the function, and we're gonna call that. We're gonna say line.match reg exp const match. And here we're going to console log the match just so we see what's happening. So this specific syntax is naming this capturing group. So now when we are launching that, you see that here we have an object that is called group that has the values in it. That's going to be super useful. So here we can say this.groups with a S, that here we just have some groups. That's perfect. We are going to create an array with that. So actually, instead of doing that, we can return, instead of doing a for loop, we can return lines.map line, and then here we can use our code, and here we can return sensor X is match. Here we don't forget to do a parseInt, otherwise we're gonna have some strings, and we know it's not a good thing because it's always comes and bite us later when we do some, when we add two strings. It just does a concatenation instead of doing a proper number addition. Okay, so here this is the beacon, and it's really important that we go and do the parsing first before doing anything else, because we need to understand a bit more about our input before we decide of our strategy, because depending on the size of our input here, we are gonna learn a lot of things. So what I would like to do here, I would like to do some pre-processing. So here this is going to be const the result, and here we return the result. But before that, I would like to define the distance between the sensor and the beacon. So here, before we do anything, we know we need the Manhattan distance, and so we're going to code this function between A and B. We return math dot the absolute value of a.x minus b.x plus math dot the absolute value between a dot y minus b dot y. That's the Manhattan distance. And here what I would like to say is result dot max distance equal the distance between result, oh, let me pause for a second. Okay, where was I? Result dot sensor and result dot beacon. So now we actually have an idea of the maximum distance. I mean, actually the distance between the sensor and the beacon. Yeah, let's just call that distance. So now, before we go and start working on part one, what we really need to do is to learn more about our full input. Depending on that, it might be quite hard. So we see the distance is approximately 1 or 2 million to the max. Actually, we can do the max. Let's display here. We're gonna say here we log math.max input.map x.distance. Now we're gonna see the maximum distance, and the maximum distance is 1.8 million. So I don't know exactly what we're gonna do with that, but that's good to know that this is huge numbers. So okay, I'm gonna take something to draw on because it's gonna be complex. Okay, so we have, basically, we are on a line and we need to know which integers are within the range of a beacon. That's really all we need to know. And here, one thing I want to check is, what about the edge case of the beacon? Is it something that we need to say this is that length? So here I'm taking the length of the string. Okay, so here we have to count everything except the beacon itself. That's good to know. So what we are going to do, I think we're going to take each beacon and we are going to check the distance here, and then we're going to mark in both directions the points that are at the right distance from the beacon. And we're going to mark that inside a set, because we don't want to display this. And yeah, I think that's gonna be it. And we're gonna go through each beacon, we're gonna do that. And we just need to make sure we take the edge case where there is the beacon on the line, and we, for example, if the beacon is here, you shouldn't mark this specific dot. So that actually we can do at the end. Okay. So now we can go back to the small input. Let's do that. And we're gonna go slow and steady, and we're gonna solve this, I believe. So first of all, const y is 10, I think, in this input, or y is 10 here. So this is something that we have to hard code. It's not part of the input. And now we can go through each of these inputs. I forgot to save here. So for of our beacon or sensor. Let's just say line of lines. We need to check first of all if line.beacon.y is equal to our current line, which is this one. In that case, we say const is beacon on line false. So we say, okay, there is actually a beacon on the line. And yeah, otherwise, here we do all of our work. So we need to check const min distance. So the minimum distance between the line and the beacon is the distance of sensor and x is sensor.x and y is this thing 10. Let's just display the line and min distance just so we see a bit what's happening. Y is undefined, so y is defined here. Oh, beacon here is not defined. Beacon line of lines. Oh no, sorry. Let's call that input of let's call that line of input, whatever. The variable names are not really good. Sensor is not defined now. Okay, yeah, so this is line.sensor. Sensor is still not defined. Here, line.sensor. Assignment to constant variable. This is not a constant variable. Okay, we see. That's good. So you can say if so here we want to discard the sensors that are too far from our line. That's the first thing we want to do. If the sensor here, if we have a sensor, let's zoom out, that is here, and that can only reach like that, then we know it will never touch the line, so we don't care about this sensor, and that's what we want to get rid of. So we need to say if the mean distance is above the line distance, actually we want to do the opposite. If the mean distance is below or equal that, then we can log do work here. I'm gonna check out of all our stuff. This is too far away. We have just 1, 2, 3 sensors that are relevant here. Let's look a bit at the input here. Line 10, we have this sensor, maybe this one. Yeah, it's not super clear. Aren't we missing some beacons here? I have a lot of sensors and very few beacons. Yeah, so anyway, I think let's just assume that this is good. So we can now just display what's interesting for us. Let's get rid of everything else. We have 3 sensors that are close enough, and so we're gonna do that. So we need to create our set. Let position, what is it? How is it called? We need to reuse the right words, otherwise it's gonna be cannot contain a beacon. Let cannot contain beacon. New set. We create a new set. That's good. Now we need to just do the right operations. So here, let's take this one for example. It is, the sensor is positioned at 4. Interesting. Let's check the example here. Here, the sensor is 1, 2, 3. Wait, do we have that? 1, 2, 3. Okay, so this is this one, this line here. We have a sensor that is 3 away, and the maximum range is 1, 2, 3, 4, 5. 3, 4, 5, 6, 7, 8, 9. What? We don't have that. Beacon is here. So this is, the sensor is at the Y, it is called 7. And X is 16, is that, no? That's interesting, we don't have the same thing here. X9, Y16. X9, no. Y7. So either I have an error in the parsing or I have an error in somewhere else. So Y7 we have position 8. Seven and 8. So that's the interesting beacon here. So we should see this beacon appearing, but it looks like it is not appearing. So we have to let's just replay again and see all beacons. We should have a beacon that is, we said, no, the sensor 8 and 7. Sensor should be 8 and 7. So that's interesting, we don't have that. Let's look at our input here. Sensor 8 and 7. So maybe I've made a mistake in the parsing. Yeah, this one is not appearing. Oh, wait, it's not appearing because I think I'm mixing things up. If the beacon is on the line Y, so Y is here. If the beacon is on the line Y, yeah, no, that's not correct. There is a problem somewhere. Let me pause for a second and find the problem. Okay, I understand what's happening. So here, I said if we have a beacon on the line, we need to say this is true. But we need to keep the sensor, because what's happening in our example here is that that was a small dumb mistake. We have this sensor here, and it has the beacon on the line, but still, thanks to this sensor, all of these places are places where there cannot be a beacon. So basically, I have to keep this if, but I should remove the else. So that we say, okay, there is a beacon on the line, but still we need to take this sensor into account. So now when we filter the sensor that are close enough, we do see our sensor 8.7. That's good. And actually here we can, if line.sensor, actually, can we just remove the line thing and say just sensor beacon and dist? Let's rename this dist. Otherwise it will clash with the function name. If we do that, then we can remove the line dot. That's just super annoying. And here this is dist. And we console log sensor beacon dist. Just a bit of tidiness so that we can code easily. So we have our thing. If sensor, what do we do with that? I forgot where we are. Let me take a second. Okay, so approximately what I want to do here, I want to do a for loop between sensor.x minus something, and that something is something like like distance minus mean distance. And so basically, if I take this here, we know like the total distance from here to the beacon. So this is a sensor here. Sensor. Here, this is the corresponding beacon. Let's remove that. This value is the distance A, let's say. And if this is B and this is C, we know that we have something like A equal B plus C. So here we want to know how far we need to iterate on this line. We just have to do something like C equal A minus B. And this is what I'm doing. Here we have the distance, which is the distance to the beacon, minus mean distance, which is the direct distance between the sensor and the line. So this is, let's actually have a function, variable const distance around x, sensor x, and we call that, we put it like this, and here we can distance around sensor x. That's not shorter, but that's just a bit clearer. So most likely we need something like that. So now let's say if distance and mean distance is equal to 0, then it means our sensor is can just reach one point on the line y. And so here we have minus 0 and plus 0, so we have just one thing. So that's good. Let's actually add our thing inside the cannot contain beacon. We add, here we're going to be using our little trick, which is we put, so I is actually, let's not use I, we should use X, because this is what's happening here. We have an X, and so here this is X dash Y, because Y is our fixed line. So we say there is a beacon that contains that, and basically I think that is all that we need to do. Let's remove a bit of debugging. We need to actually console log cannot contain beacon.size, and here we have to do minus if there is a beacon on the line. In that case we do -1, otherwise we do -0. And we have 26 things. 26 position where there cannot be a beacon. Yeah, I think this is quite okay. Don't hesitate if anything is unclear to share that, to ask questions in the comments. Let's see how quickly it goes. Oh damn. So let's see how long it takes. So here you see we have something that is taking quite a lot of time, like 5 seconds. So that means most likely there is a solution that goes a lot faster. But to be honest, I think we are doing good because we are discarding the sensors that are too far. We are only taking into account the sensors that are close enough. I mean, one thing we could do is have like intervals. So instead here of going through the for loop, we can have intervals. That's an option. You can have intervals and add all the intervals. The problem is that it's quite complex to manipulate intervals, especially in JavaScript, because there is no really function for that, and I would have to write complex stuff to manage intervals. So I think for part 1 we're just gonna keep that. Let's actually make sure this is the right answer, otherwise I have to go back to the drawing board. Not the right answer, so the answer is too low. Okay, so it means I am missing some values. So let's keep that here. We say this is too low. Interesting. There could be several beacons on the line, right? So this might not be correct. But we say our answer is too low. Beacon on the line. Let's see. Let's see how many beacons we have on the line with the full input. Okay, so we have no beacon on the line. That clears this edge case, because I was thinking there could be several beacons, and then okay, so this is kind of an edge case that we're not covering, but it's not a problem because there are no beacon on the line Y. Oh, I know. This is for this big input we have actually a different Y. We need to have Y equal this huge number. Oh my god. So actually I should keep this here. Console.log beacon on the line, just to make sure we are not doing any mistakes. So here it takes 10 seconds to do this. Let's run that again and see how many beacons we have on the line. Oh, okay, so we have several beacons on the line. So let's drop this. This is not a boolean. This is now an integer. So here if we have a beacon on the line, we do beacon on line plus plus. So now it's going to be a lot simpler because we just have to do minus, not is beacon on the line. We're going to say, we're going to rename that to total beacon on line. Or total beacons, maybe beacons. Let's see that. So now we are handling when there is more than just one beacon. They can be from 0 to an infinite number of beacons on the line. Yeah, I think the rest of the code is good. We have the right y for this part, and we have this value. Let's see. Yeah, this value is bigger than the previous one, so I think we should be good now. Let's see. Oh damn! It looks like it's a day where we are making mistakes. I mean, that's good. That's good. We're gonna fix it. We're gonna fix that. Oh, one thing to speed things up. Here, we don't care about y because y is a constant. So we can actually just add x to the set. Is that speeding things up? Let's see. That is speeding things up like crazy. We went from 10 seconds to 2 seconds. So it looks like that was not a good thing to do. So now we have something that's good. I mean, something that's faster, but we are too low. So it is hard to know how we can debug that. Because if we go back, let's try to go back to the small input. So this is the small input. Let's see. Now we know we need to have 10 here for the small input. Oh wait, 24? Oh, so that's good. I think we made a mistake now. Let's see. For the small input it's 10 and we should have 26. That's good. We are finding some issues. So here let's display the sensor beacon. Let's display the sensor and beacon that is in range. Let's display also dist and mean distance. We display everything and we're just gonna think about that. So here they don't tell us exactly how many sensors are relevant. Consider the sensor 8, 7. We can actually have a function let total here, total plus plus, and here we display totals that we see how many. So the sensor 8 and 7. There isn't the sensor 8 and 7 again. Oh yeah, 8 and 7, okay, it is here. So the sensor 8 and 7 is blocking how many length? 12. It should be blocking 12. How come this is not displayed? Let's see. It is blocking 13. Oh yeah, okay, 13. That's normal because we have total beacon online that is gonna be 1. We have too many beacons online. Here we have 0, 1, 2, 3. What the hell? Why do we have so many beacons on the line? Let's look. Most likely this is the problem. So the beacon here, y is equal to 10. So it's normal that here it goes from 0 to 1. Here it is again to 10. So it cannot be. There is a problem somewhere because we have several times the same beacon here. I'm gonna check myself and report what I find. Yeah, so actually there can be several times the beacon on the same line. So that's something that I wasn't thinking about. So that's an edge case. So we're gonna say let beacons online. We need to deduplicate the beacons online. So now we're gonna do that. Beacons online dot add, and we add beacon.x. That's interesting. We've made some mistakes on managing these beacons, where these beacons are on the line. So now we can say beacons online.size here. Let's just remove all of this because I think I've solved the problem. So now we can clean up the code. If there's a beacon on the line, then we add it to the set so that if several sensors find the same beacon, it goes well. Let's see now. We have 26 again. So now I think we can go again to the full input. This is an adventure today. We really have like a lot of hope, then it's not going well, then we find some issues, we fix it. Okay, so now we copy pasted the right Y. Let's see how much time it takes. It takes less than 2 seconds, and this is the number that we find. And this is the number that is higher than the previous one, so that's good. So we can paste it here now. Let's see. Oh yes, yes, yes. This feels a lot better when you struggle. I don't know about you, but when you struggle and you get the star, it feels good. Let's go to part 2. I'm gonna read this problem statement. Okay, I think we have a problem here. Because now we know the distress beacon is between 0 and 4 million on X and Y, and it's just like the only place that isn't found by this. So this means the solution that we have for the first puzzle isn't the right one. I mean, it's not the most optimized one, and so for part 2 we're just gonna break our neck. It's not gonna work. Because I'm gonna write quickly the code that I think would work. So we're gonna take part 1. We're gonna actually try to solve the example here, and then we're gonna think how to make this better. So we take the small example here. What do we do with it? Here, this is line, no, this is not line 10. We need to, between 0, I think it's between 0 and 4000. So here, const max coordinate, and here this is just gonna be 20. So basically one way to do that would be to do a for off, and that wouldn't work, but let's do a for loop. Y between 0 and max coordinate, a double for loop. I know this is not going to work, but still I want to code it. Maybe we find some good optimization after having this coded. So we have this, and here we need to check we actually go through each beacon for of yeah, this is a 4 of, oh my god, line. Actually, no, it's not line, that's here, this thing. And what do we do here? We check the distance, we check if distance between x, y, and the sensor is below or equal dist. In that case, we let found equal false. Here we say okay, here we have found a sensor that sensor that is within the right distance, which means this is not a valid candidate. And here we can break out of the inner loop, and here we say if not found, then console log. Okay, so here what do we need to do? This is the beacon position. We have to multiply by this, so it's x, x times this, so it's x times this plus y. And yeah, I think that's all. So I think here we can remove all that, and here we can go out of the, we can stop computing all these things. Okay, so this is the dummy way to solve this. Yeah, here on the first line we get 0 because we have the small input, and so yeah, makes sense. Actually, you know what? I think I can code that. I'm gonna check here if input.length is equal to 14. In that case, this is 10. Otherwise, this is what is this big number? It's that. Yeah. Okay. Okay, we fixed part 1. Now we never have to change this again. We can actually do the same here. Max coordinates, we can say same. It's either 20, otherwise this is like 4, the same number here, 4 million. Yep. Okay, so now we have our number, but for sure if we go, I'm gonna try just for fun, but if we paste the full input, it's gonna last forever. Let's wait like 20 seconds. So okay, so here we have our first result that was taking already a bit of time. I'm gonna wait 30 seconds. Okay, I've waited, I don't know, around 30 seconds, and we see the program is not completing, which means the triple for loop is not a good solution. Who knew? So I feel a bit unsure. So I think we should reuse the logic that we have in part 1 somehow. We could try to actually to do that. we go through each y and then we repeat this logic. And if there is yeah, we can try that. Let's try that. I'm not sure how good it's gonna be, but you know what, let's just try. So we have this thing. Yeah, I don't think we really want to keep this dummy implementation, so we're just gonna trash it. We can comment it out. Oh yeah, you know what, let's comment it out, dummy implementation, so that's you can see the code if you're using it. If you're like going in the GitHub repository, you can see what happens. So here, this is the idea. Here we go between 0 and max coordinate, and we're gonna do this, and we're gonna check. Here, this is const available is equal this. Actually, if there is already a beacon, we don't care if there is already a beacon. Yeah, we don't. We just do. We don't care about that there is already a beacon. We just care about max coordinate minus, and here we display y and available. Let's try that. This is part 1, and here this is part 2. Okay, this is not working at all. Okay, I think here so the thing is, here we have like a huge space and we want to restrict it. Yeah. So here we need to optimize this, because here most likely, let's actually display one of those. If x below 0 or x above max coordinates, console log, oops. So what I'm trying to understand is can we, okay, there's a lot of oops, so we can, that's good, okay, that far too many oops. So here we need to make sure we never go below 0 and we never go above max coordinate, because this can go a lot, like this is an infinite space, so we need to restrict our space around this, in this interval. So here we can say math dot I'm not sure what I'm doing here. So what I would typically do, I would clamp this starting position that can be so we need basically let from, this is this one, let to, this is this one. Here we have from and to. What we need to make sure, from is between 0 and 4 million. I mean, we need basically to do here the intersection between from 2 and 0 max, what is it? Max coordinates. Max coordinates. I wish we had this kind of thing inside JavaScript, but because we don't have it, we need to do it manually. So this is what I would do if from is below 0, from equals 0, if if 2 is below 0. In that case, we know there is no intersection. So here we can just skip this sensor. If 2 is below 0, we can skip. So we do continue. We skip. If from is above max coordinates, we can skip as well. Not a problem. That removes two things. So now 2 needs to be above 0 and from needs to be below or equal max coordinates. Are we taking into account both 0 and max coordinates? No lower and no larger. Okay, so this is inclusive. So we have two intervals that are inclusive. From is part of the interval, 2 is part of the interval, 0 and max coordinate are part of the interval. So with that, let me just think for a second. Yeah, I think with that, we know that there is an intersection. So now we need to take from, this is called math dot the maximum between 0 and from, and 2 is math dot the minimum between max coordinates and 2. I believe with that we should always be within the range. So from and 2, we only take what's interesting, what is between 0 and max coordinates. Now if we do that, so it takes quite a while for the okay, max coordinates is not defined. Max coordinate without the S. Let's see that again. Part 1 is quite slow, we know. Let's see part 2, 0, minus 1. Okay, why do we have minus 1? Max coordinate. Okay, I understand. Yeah, this is an off by 1 error, because max coordinate, we have both 0 and the maximum that is taken into account. So here, as you can see, this is super slow. Okay, so see, here we are basically checking each line and we see how many open slots there is on each line. And as you can see, this is taking maybe 1 second per line, which means we have 4 million lines. What is it? 4 million divided by, that's going to take 1000 hours to compute. Not really good. So it's time to go back to the thinking scenario and see how can we make this go faster. Okay, I've just added this, which is giving us how many operations we are doing in this most internal for loop. oh, I forgot to press save. The idea is that I would like to understand if we need to just remove this internal. Oh yeah, look at that. We have like so many operations that are happening here. So what we're going to be doing, basically, we're going to be changing from this for loop to actually merge different intervals. So basically we have here the from and to interval, and this is the line y. So here we're going to say const intervals. Here we don't care about the beacons, we just have the interval here, and we say intervals that push from to. And remove that, and basically here we should display the intervals here. And the thing is, so this should go quite fast. Yeah, you see it's going quite fast. But here we need to merge these intervals into just one big interval, and we see, is there a hole in this interval or not? So I believe if we want to merge the intervals, we need to sort them first by the first element. So this is sort in ascending fashion, a0 minus b0. So let's see, here, just run that. Okay, I think I need to comment out part one, otherwise we just, okay, so we have this, and then we need to go through each element and see if through two elements and see if we can merge them or not. So for loop I, it starts at 1 because we want to take the current and next element, and it's not array, it's intervals, and here we can say need to check if intervals I minus 1 of 1, so the end of the previous interval is above or equal the start of the current interval. In that case we can merge them. And how do we do that? We do of 1 equal, no, yeah, of 1 equals intervals I of 1. And we can remove intervals dot splice. How do we do splice? We need to remove one element at the rank, at the position I, and we need to delete one. Now we need to stay on the position I, so we're gonna do I minus minus. Let's see that. Is that working? Is that not working? Am I doing a crazy thing? Okay, that is working super fast, as you can see. I'm really enjoying that. And now we just need to check interval.length. If this is equal to 1, it means that we have one interval that fills the full range. Otherwise, if not that, in that case, what do? We console log intervals, y intervals, and we return. Oh, that's really good. I think we are getting somewhere. So the part 1 is always slow because I haven't touched the code for part 1. The part 2, beacons on line, is not defined, so there is most likely, what is beacons on line? Oh yeah, we don't care about beacons on line anymore. We can remove also here the beacon here. We not taking care of it. Let's see. Is it quick? Is it not quick? Oh, this worked. No, this worked, but we didn't see anything logged. So that's not cool. Oh wait, that doesn't make sense. If interval length is above 1, in that case, we need to log something. So it lasted, oh my god, this is working. Is it? Oh yeah, we have like actually a big hole, which makes no sense. Actually, we're not gonna return, we're gonna display, and maybe we have made a mistake in our code to join the intervals here. So yeah, I think I'm gonna pause, I'm gonna eat and come back and think and solve that. So one thing I'm thinking is that maybe I'm not doing the right stuff here, the intersection here. So I am not gonna do this intersection here. Just gonna take the full interval for each line. And we're gonna try to merge them. And here we're gonna display the intervals no matter what. And we're gonna see what happens. Okay, so that's good here. We always have just one interval. So I think we need to do the intersection. Now we need to do the intersection because maybe I was like making some bad thing here. So now we need to do the intersection. I think I need to read a bit about intersection of intervals on the web. Okay, so we're gonna do that. I think the code is correct here. From what I'm reading on the web, it looks really good. But we're gonna do the intersection here now. We're gonna go through for result. We're gonna go for each interval of intervals. We check if the end of the interval is actually, let me check here this code that I've found, this pseudocode. It's really good. The start is above the end. Okay, so if the start is above the end, or the start is above the end, in that case we continue. Otherwise, there is an intersection between the two intervals and we need to do res.push. That's interesting to do all this interval thing. The start is the math.max between the two starts, so interval 0 and 0, and math.min between the two ends, so interval of 1 and max coordinates. So that gives us yeah, I think only now we can do this thing. Let's see here. Yeah, I think it was correct, this code. Anyway, let's try that again. Okay. Is that, no, that's not correct. You see, there's so I have a problem where there are several lines that have huge splits in them. So maybe I'm not understanding the prime statement correctly. By the way, we have the full input here, so that's not good. We need to go back to the small input so that we can debug a little bit more easily. So yeah, line 0, we already have like a space of 2. Oh, I should have res actually here, not interval, we should have res. And here, yeah, we have between 0 and 20. And here we have, yeah, a spot of 2. Have huge holes here. Not good. So could it be when we merge the two intervals, we check if there is an overlap between the two. We have sorted the intervals by increasing order from the start of each interval. We check if the end of the previous interval is above or equal to the start of the current interval, and in that case we merge the two. We remove the interval of I, and we do I minus minus. That should be good. Yeah, that is most likely a small nasty bug somewhere. First day where we are a bit lost. I think I'm gonna poke around the code offline outside of the video and see what we can do now. I have an idea. In order to debug that, we're just gonna do here y equal 10, which was the thing that we were interested in, and here we just return. So basically on line 10, we know we should have this pattern here. It's not what we have, so that's good. We are going to display here console log intervals. Let's sort them already here. So we display the intervals after they are sorted correctly. -2, 2, 2, 14. Okay, so here you see -2, 2, 2, 14. Have an issue here. We can say here console log interval of I minus 1 interval of I, and then after the merge it becomes intervals of I minus 1. So let's see. So here those two should be merged. It becomes this thing. Oh no, this intervals of this end should be math.max between interval this and the current value. Because if the first interval ends after the second interval, then we shouldn't put 2 here, we should keep 14. So that's the mistake. And now if I remove a bit of these console logs everywhere, 26, it's not what I wanted to see. I wanted to see just here console log res. Okay, 0, 20. Okay, so I think here I have fixed this. So we can remove y equal 10. So that was a mistake with the merging here. Here we say if there is more than one interval, we display and we return. Let's see. We actually have a big hole on line 11. is that normal? Is that what we wanted? We didn't want a big, oh yeah, we do, that's perfect. It's just the coordinate 14 here that we care about. So here we can actually console log intervals, no, res of 0 and plus 1. This is gonna be the coordinate x that we care about, 11, 14. So now we need to do, so this is x const x equal that. So you can do x times, I think it was 4 million plus y. What do we have? We have this exact thing. So now let's try and take the full input again. I think I'm really excited. I think it was a bit of struggle, but we have made, so the first part is slow and the second part is, wow, that's looks far too big. Let's see. Let's see if this is correct or not. Let's go. We have finished day 15. That was intense. If you watched until now, don't forget to drop a like, drop a comment also that you watched until the end. And yeah, thank you so much for the support in this series. See you in the next one. Bye bye.